Checkpoint 1, Solving Linear Equations, Part 1, Integer Coefficients. Equations in one variable may be solved in a variety of ways. Commonly, the first step is to first simplify by combining like terms. Next, isolate the variable on one side and the constants on the other. Finally, divide to find the value of the variable. Note, when the process of solving an equation ends with different numbers on each side of the equal sign, for example, 2 equals 2, there is no solution to the problem. When the result is the same expression or number on each side of the equation, for example, x plus 3 equals x plus 3, it means that all real numbers are solutions. So let's take a look at the examples. For the first example, solve 4x plus 4x minus 3 equals 6x plus 9. So the first thing that they had to do is they had to combine their like terms. So you can see we have a 4x plus 4x. Now remember, when you're combining like terms by adding, you need to add only the coefficients. So 4x plus 4x is 8x, not 8x squared. There aren't any like terms on the right-hand side. You'll notice you have an x for this one, and you have a constant or a number without a variable for the second one. Remember that you cannot combine numbers that have variables with numbers that do not. Furthermore, you must combine numbers that only have the same degree. So if I have a variable with an x, I can't add it with a variable that has an x squared. So 4x plus 4x gives us 8x. So now I have 8x minus 3 equals 6x plus 9. In order to cancel out things on each side, we're going to add and subtract the opposite. So if you look here, the opposite of negative 3 is going to be positive 3. So they add 3 to both sides. Negative 3 plus 3 gives you 0. And over here, 9 plus 3 gives you 12. Now, I don't like that the book did everything in a single step, but there's nothing wrong with that. So we also have an 8x and a 6x. So the opposite of 6x is going to be negative 6x. So they subtracted. 6x minus 6x gives us 0, so we're just left with 12. And 8x minus 6x gives us 2x. So now I have 2x equals 12. I then divide both sides by 2, so that I get x equals 6. Now, of course, we always want to make sure that we check our answers. And the way that you check your answer is you're going to take your final answer here, and you're going to replace every time you see x, because remember, this is saying x is the same as 6. So we're going to take every time we see an x in the original equation. It is important that you always go back to the original equation, as that is where you started. You don't want to plug it back into anywhere that you've already done some work, because we're trying to find out if we made any errors. We're trying to double check and make sure everything is perfect. Now, you'll want to make sure that you always check your work on your homework, because you want to get in the habit of checking your work so that way when you take your test, you'll be able to be successful. So, we have x is the same as 6. So I went in here, and anytime I saw an x, so we have 4x plus 4x minus 3 equals 6x plus 9. So I replaced all 3 of those x's with a 6. So I now have 4 times the quantity 6 plus 4 times the quantity 6 minus 3 equals 6 times the quantity 6 plus 9. So 4 times 6 is 24, and 4 times 6 is 24. And then 6 times 6 is 36. So that's where those numbers are. And we just bring the negative 3 down and bring the 9 down. 24 plus 24 gives you 48. 36 plus 9 is 45. When you subtract 48 minus 3, you get 45. And since 45 is equal to 45, 6 is the correct answer. Something worth noting, if you want to just type 4 times 6 plus 4 times 6 minus 3 in your calculator, it'll give you 45. and then you can type 6 times 6 plus 9 into your calculator, which will also give you 45. So if you want to skip this middle step and not show this work, that's okay. We'll understand that you used your calculator for this part. So now let's take a look at some of the other examples. So for this first one, we have 3x plus 7 equals negative x minus 1. There aren't any like terms on the same side of the equal sign, so we don't have to worry about combining like terms on either side. So right off the bat, if we have negative x, we can add x to both sides. Negative x plus x will cancel each other out, and 3x plus 4x will give 3x plus 1x, will give me 4x. Over here, we have 7 equals negative 1. So if I subtract 7 from both sides, 7 minus 7 will give me 0, leaving me with just 4x. And negative 1 minus 7 will give me negative 8. So now when I divide both sides by 4x divided by x will just leave me with an x. A lot of students ask why we don't write a 1, since 4 divided by 4 is 1. And there's not really a good answer other than we use x so frequently that we just don't see a reason to write it. It's just a commonly accepted understanding that there's a 1 in front of that x. However, if you want to write a 1 there, if that just makes it a lot easier for you, you are more than welcome to do so. So we have negative 8 divided by 4, because again, that's what we're doing on both sides, gives you negative 2. For these, they didn't show plugging their answers back in, but if you do go back and type it in your calculator, you will see that it works. For part B, you have 1 plus 2x plus 5 equals 4x minus 3. So now you should hopefully notice that you have a 1 and a 5, which are both constants on the left-hand side of the equation. So you need to add 1 plus 5, which will give you 6. So now you have the equation negative 2x plus 6 equals 4x minus 3. I add 2x to both sides because we like to keep things positive. So negative 2x plus 2x cancels, and then 4x plus 2x gives you 6x. I then add 3 to both sides, so 6 plus 3 will give me 9, and negative 3 plus 3 will give me 0. So now I have 9 equals 6x. I divide both sides by 6 because I want to get x by itself, and 9 divided by 6 will give me 1/2, and 6x divided by 6 will give me x. Alright. For part C, I have 4x minus 2 plus x equals negative 2 plus 2x. So again, I need to combine my like terms first. So I have 4x plus x, which will give me 5x. I bring down the negative 2. They chose to rewrite negative 2 plus 2x as 2x minus 2. They didn't have to do that, but like I said, for math teachers, we always like to write first things in descending order. So we like to put the constants after the variables. So I have 5x minus 2 equals 2x minus 2. I subtract 2x from both sides. So 5x minus 2x will give me 3x, and then the 2x's will cancel. I add 2 to both sides so that 3x equals 0. So now I have 3x equals 0. Some of you are probably saying, well, 3x doesn't equal 0, so it's no solution. But remember, I have a variable on the left, and I have a constant on the right. So I can keep going. When there's no solution, you'd have a number, like 3 equals 0. And so that's when you'd have an instance of no solution. So I divide both sides by 3. 3x divided by 3 gives me 1x, which I write as just x. And remember, 0 divided by 3 is still 0. So my answer is just x equals 0. So now let's look at part D. 3x minus 4 plus 1 equals negative 2x minus 5 plus 5x. So I combine my like terms. Negative 4 plus 1 will give me negative 3. Negative 2x plus 5x will give me 3x. And I just bring down my negative 5, and I bring down my 3x. When I subtract 3x from both sides, 3x minus 3x is 0, and 3x minus 3x is 0. So now I have negative 3 on the left and negative 5 on the right. Since negative 3 does not equal negative 5, that's where my no solution comes in, is because these are not equal equations. So now let's take a look at two of the problems that you're supposed to be working on this summer. So the directions ask us to solve each equation. So for number 1, I have the equation 2x minus 3 equals negative x plus 3. So the first thing I want to do is see if there's any terms that I need to combine. There aren't. I have a variable and a constant, and a variable and a constant, and I can't combine those with each other. So the first thing I did, and I did these as 2 steps to make it more obvious for what I was doing. So the first thing I did is I added 3 to both sides. So you can see negative 3 plus 3 will cancel out, so I'm left with a 2x. And then my negative x comes down, and 3 plus 3 will give me 6. So now I have 2x equals negative x plus 6. So the next thing I want to do is I want to get my variable over here on the left-hand side. So I add x to both sides, because negative x plus x will cancel each other out. 2x plus x gives me 3x, so I now have 3x equals 6. Since I want to have x by itself, I'm going to divide both sides by 3. Alright, because now my 3's are going to cancel, because 3 divided by 3 is 1, even though we don't write it, and then 6 divided by 3 is 2. Now hopefully you aren't sitting there and saying, alright, we're done with the first one, because what you have to remember is we need to go back and we need to check our work. So to check your work, you're going to take 2, and you're going to substitute it in for the x on both sides. So I underlined it in orange so you could see where I was substituting it back in. So I have 2 times 2, 2 times x, so 2 times 2, minus 3 equals the opposite of 2, because it was a negative x, so it's the opposite of 2, plus 3. So 2 times 2 gives me 4. Negative 2 plus 3 is 1. And again, you could plug this in your calculator if you'd like and see if these give you 2 equal things. I'm just showing you all the work. So now I have 4 minus 3, which is in fact 1. So my answer is correct. So now let's take a look at problem number 9. So now for number 9, I do have some numbers I need to combine, and I've underlined them with highlighter. So I have negative 4 plus 3x minus 1 equals 2x plus 1 plus 2x. So the first thing I need to do is combine my like terms. So negative 4 minus 1 is going to give me negative 5. And again, 2x plus 2x is going to give me 4x. So I have negative 5, since negative 4 minus 1 is negative 5. Now, normally you'll see your teachers write 3x minus 5, but I wanted to show you that you could really do it either way. So that's why I wrote negative 5 first this time. So you have negative 5 plus 3x equals 4x plus 1. So the first thing I wanted to do was to get my variables on the same side. So I subtracted 3x. Positive 3x minus 3x is going to cancel out, leaving me with a negative 5. And a 4x minus 3x is going to leave me with x. So now I have negative 5 on the left and x plus 1 on the right. I then want to move my 1 so that I have just my variable by itself. So I subtract 1 from both sides. Negative 5 minus 1 is going to give me negative 6. And then 1 minus 1 will leave me with just x. And since x is already by itself here, I already have a 1x because I had 4x minus 3x. I don't have to do anything further, and I just know x is equal to negative 6. Now, obviously we aren't completely done since we want to go back and check our work. So again, every time I had an x, so we had 3x, 2x, and 2x, I replaced it with a negative 6. Move that So I have negative 4 plus 3 times negative 6 minus 1 equals 2 times negative 6 plus 1 plus 2 times negative 6. So the first thing I did was my multiplication, going through my order of operations. 3 times negative 6 is going to be negative 18. 2 times negative 6 is going to be negative 12 for both of those. Negative 4 minus 18 is negative 22. Minus 1 is going to be negative 23. Negative 12 plus 1 is going to be negative 11. Minus 12 will be negative 23. So again, my answer works, and I have the right answer. So again, you want to make sure that you are always going back and checking your work in order to make sure that you did everything correctly. If you're still feeling a little confused about how to solve linear equations with integer coefficients, feel free to email me at mbrenner, mbrenner, at du131.org, and I will try and give you as much help as I can. Thank you and have a nice day.